Assalamualaikum and a very good morning. Here, my name is Muhammad Adi. We will be presenting of our workplace assessment, which is chemical health risk assessment that been done at Makmal Kimia Analysis at UiTM Shah Alam. Our fellow group members are here, dedicated below. We have 8 group members. So let's move forward to our introduction.
Next, let's look at our outline. First, introduction and objective. This will be presented by Muhammad Zuhairi. Second, scope and work description. This also will be presented by Nur Shazin Aisha. And then third, assessment methodology. And this will be presented by Fahim Abukari. And fourth, assessment finding. This also will be presented by Muhammad Adi. And last but not least, discussion will be presented by Linisa Nur Amsa. And lastly, recommendation and conclusion will be presented by Muhammad Shafiq and Amjad Azmi.
Introduction to the legal framework of this presentation under the Occupational Safety and Health Act 1994 and Use Regulation 2000. Employer must not carry out works involving chemical hazardous to health unless a proper chemical health risk assessment has been conducted. This CHRA was conducted at Makmal Kimia Analysis, Faculty of Applied Science, UiTM Shah Alam, from 14 April 2026 to 9 June 2026 under the guidance of Dr. Nur Suhaila Muhammad Hanafi and Lab Assistant Encik Yusri Zulkafli. Objective of the assessment: identify chemical hazard in A607 Analytical Chemistry Laboratory and evaluate how chemical hazards to health are used. Second, determine specific health risks based on how chemicals are handled across inhalation, dermal, and ingestion route. Third, assess the effectiveness of current control measures already in place: LEV, Finhood, PPE, emergency facility. And fourth, fulfill legal duty under OSH Act 1994 and Use Regulation 2000, ensuring total compliance with national safety regulations.
Next, I will explain the scope and work unit description of this assessment. The work unit assessed in this study is the Analytical Chemistry Laboratory Assistant at Makmal Kimia Analysis UiTM Shah Alam. This assessment focuses on the laboratory assistant because this worker is directly involved in handling chemicals during daily laboratory operation. The main tasks evaluate include mixing, pouring, and storing chemicals, as well as assisting students during practical laboratory experiments. These activities may expose the workers to various chemical hazards, so it is important to assess the risk and existing control measures. This assessment was conducted from 14 April 2026 until 9 June 2026. During this period, a total of 23 chemicals used in the laboratory were identified and assessed. Based on the work unit details, there is one male laboratory assistant and no female workers assigned to this work area. The main responsibility of the laboratory assistant is to monitor and prepare chemicals and laboratory equipment for teaching and learning activities. To control exposure to airborne contaminants, the laboratory is equipped with local exhaust ventilation, or LEV, which help remove hazardous chemical vapors and maintain a safer working environment. This scope allows the assessment to identify potential chemical hazards and evaluate the effectiveness of existing control measures in the laboratory.
Next, I will explain the assessment methodology using the Chemical Health Risk Assessment, or CHRA. The assessment was carried out in 6 main steps. First, we conducted a walkthrough inspection of Makmal Kimia Analysis, or laboratory A607. During this inspection, we observed the work environment and identified all the areas involving chemical storage, chemical usage, and chemical waste handling. Second, interviews were conducted with the laboratory assistant together with delivery of the safety data sheet, SDS, for all 23 chemicals used in laboratory. This allowed us to identify each chemical hazard, classification, and H codes. Third is hazard identification. Each chemical was assigned a hazard rating ranging from 1 to 5 based on the CHRA manual. The hazard were assessed through 3 possible routes of exposure, which are inhalation, dermal exposure involving skin and eyes, and ingestion. The fourth step is risk estimation. The risk rating was calculated using CHRA formula, where risk rating equals hazard rating multiplied by exposure rating, or RR equals HR times ER. The final score was then categorized into low, moderate, or high risk. The fifth step involved evaluating the adequacy of existing control measures. We assess whether the current technical controls such as isolation, engineering controls, and personal protective equipment were adequate, inadequate, or not applicable. Finally, action priorities were assigned based on the level of risk and any gaps for the existing controls. Chemicals with higher risk require more immediate corrective actions, while lower risk chemicals only require routine monitoring and maintenance of existing control measures. Overall, all these 6 steps ensure that the chemical health risks in the laboratory are assessed systematically and that appropriate control measures are recommended.
So moving forward to our assessment findings, where 20 three chemicals are declared with three route of entries, which is inhalation, thermal, and injections. So we've identified 9 high hazard with category 3 and 4, and we also identified 6 chemicals that are also in AP1 and AP2, which in need of priority actions. So we take an example of phenolphthalein, where its HR category is 4, while its inhalation RR is on 8, and thermal risk in H1, which is conducted high. So meaning it needs an AP1 priority action. So moving forward, there is also AP2, AP3. So moving forward, for hydrochloric acid and ethanol absolute.
Okay, for assessment findings, routes of entry, and control adequacy. So to understand these findings, we must look at the risk equation. Risk is the product of hazard and exposure. We evaluated how chemicals enter the body through three primary routes: inhalation, thermal contact, and injection. Based on the severity of the hazard and the magnitude of worker exposure, we have assigned risk rating, which is RR, action priorities, which is AP, to guide our safety improvements. So for inhalation hazards, identified several chemicals of concern. Phenolphthalein carries the highest risk rating at RR 8, followed by hydrochloric acid, EDTA, and propane 1OM at RR 6. We also review nitric acid, which is RR 4, and acetic acid, which is RR 2. Because the risk is determined by the likelihood of a chemical becoming airborne, the primary control measure required is that all volatile chemicals must be handled exclusively within fume hoods to prevent these substances from entering the worker's breathing zone. So and the for thermal exposure, the most critical finding concerns thermal exposure. We identify 6 chemicals with high thermal risk: H1, ammonia solutions, hydrochloric acid, nitric acid, phenolphthalein, sodium hydroxide, and sulfuric acids. Current evaluations show that our personal protective equipment (PPE) is inadequate for these 6 substances. Per the hierarchy of control, while we look into engineering solutions like isolation or enclosure, we must immediately upgrade our PPE selection to ensure it matches the specific corrosivity and absorption properties of this chemical. For ingestion, regarding ingestion, chemicals such as acetic acid, ammonium chloride, ammonium nitrate, 1-butanol copper acetate, and EDTA have been assigned an action priority, which is AP3. An AP3 rating indicates that while the risk exists, it is currently considered adequately controlled through administrative and organizational measures. To maintain this status, we must strictly enforce our no food or drink policy in work areas to ensure all personnel follow rigorous hand washing protocols to prevent accidental chemical transfer.
So moving forward to our additional findings, where we detected 2 problems with scheduled waste and first aids. Firstly, for scheduled waste containment, the containers are placed at open spaces and open corridor, which is violates the regulatory in our Environmental Act. And moving forward to our first aids, we detected that the first aid box has insufficient equipment of first aid and has not been updated for a while, meaning lab assistant has failed to follow these regulations and making the lab unsafe condition.
We start by technical control. For LUV, fume hood, it is adequate, which is sufficient for volatile reagent. For PPE, such as neutral glove, safety goggle, it is also adequate for tintas. However, there are 6 chemicals show inadequate PPE for high thermal risk tasks. Next, for organizational control, there is no written job hazard analysis (CHRA) for corrosive chemical, no structured recorded chemical safety induction program, and no dedicated rest area separated from chemical zone. There is partial SDS available, but no formal chemical register maintained. Last but not least, emergency response preparedness. There is no chemical speed kit available, no emergency eye wash or safety shower in the lab, no formal incident reporting procedure, and for fire extinguisher, it is accessible and regularly inspected. For note, there are acid splash incident occurred in 2022 and documented. Worker health and exposure monitoring. For current health status, worker, which is the lab assistant, report no current adverse health effect or complaint related to chemical exposure. Susceptible group, workers with pre-existing respiratory, thermal, or ocular condition are at high risk and must notify supervisor before chemical handling duties. Monitoring status. No baseline personnel air exposure monitoring, 8-hour CWA has ever been conducted. Biological monitoring. No biological monitoring or health surveillance program in place for any chemical.
First-time implementation required. Medical surveillance triggered. If TWA monitoring result show more than 50% of PL for any chemical, a medical surveillance program under a dash registered occupational health doctor (OHD) must be initiated immediately. Carcinogen risk detail. Phenolphthalein. Category 1B carcinogen may cause cancer, suspected of damaging fertility, or the unborn child. May cause damage to organ through prolonged exposure. Fatal if inhaled. Methyl red. Category 2 carcinogen. Suspected of causing cancer, may cause damage to organ through prolonged exposure.
Are our recommendation split into three priorities level. First, immediate action. Those need to swap out two cancerous chemicals, phenolphthalein and methyl red, for several indicators. Then switch from manual pipetting of acid to automated dispenser, so less direct contact, and installing an emergency shower and eye wash station in Makmal A607. They also need adding a spill kit and setting up a proper way to report accident. Second, remedial action. This take a bit more time. Better PPE, heavy duty glove, splash goggle, full face shield, writing safety for user for highly corrosive chemical, a safety training program for staff, a full register of all categories chemical that are used, and baseline testing to see how much HCI, nitric acid and ammonia vapor people are actually exposed to. If it high enough, they need to go to the clinic to medical check. Third, ongoing maintenance, yearly testing of fume hood ventilation. Make sure all volatile chemicals are only handled inside the fume hood and no food and or fluid in the lab. Set up a separate rest area instead. Next, exposure monitoring and CHRA review. This slide explains the role behind the monitoring. The existence need to be tested for quick chemical HCI, nitric acid, and ammonia vapor is using standard NIAS test method. If exposure hit 50% of the safety limit, the trigger for medical check. Also, it is required to review the whole risk assessment regularly, at least every 5 years or sooner if we start using different chemical or method. If exposure stay low for the two tests in a row, we can test less often.
Okay, so to conclude our chemical health risk assessment at Makmal Kimia Analysis A607 at UiTM Shah Alam, we identify a total of 23 chemicals used by the laboratory assistant with risk evaluated through inhalation, dermal, and ingestion for exposure routes. And overall, we found that the laboratory already has some effective control measures, such as local exhaust ventilations, known as LEV, fume hoods, and well-maintained fire extinguisher. These controls help reduce the risk of chemical exposure during the normal laboratory operations. However, our assessment also highlighted several important areas that require immediate attention, like two carcinogenic chemicals like phenolphthalein and methyl should be substituted with safer alternatives. In addition, 6 chemicals present a high dermal risk, and indicating that the current personal protective gear and isolation controls need further improvements. We also identified the absence of essential emergency facilities such as chemical spill kit, emergency eye wash, and also shower stations. These are very critical for responding to chemical accidents. Furthermore, improvements are needed in organizational controls, including establishing a formal job hazard analysis, chemical register, and structured chemical safety training. Regular exposure monitoring and medical surveillance should also be implemented to ensure the long-term worker health and compliance with the use regulations. So, to conclude this, a chemical health risk assessment is not just a legal requirement, it is an essential process to protect workers, minimize occupational illness, and also create a safer laboratory environment. By implementing the recommended control measures according to the action priorities, the laboratory can significantly reduce the chemical health risk while maintaining the compliance with Malaysian occupational safety and health regulations. Thank you.